For lesson 5.03, angle properties, we're going to start off by reviewing over some of the angle relationships that we've recently and previously discussed, starting with the vertical angles and the linear pair. Remember that vertical angles are the two non-adjacent angles formed by intersecting lines, and you can see the angle pairs that are congruent in that particular set, angle 1 and 3 and 2 and 4. You also have the linear pairs, which are two angles with a common side and vertex, and they are going to have sides that also are pointing in opposite directions, like opposite rays, and they have no overlapping regions either, by the way. That's what makes a linear pair, and they are supplementary, which brings me into my next angle relationship that we've discussed: complementary angles and supplementary angles. Complementary angles are two angles that have a sum of 90, and supplementary angles are two angles that have a sum of 180. Now, in that particular instance, you can have complementary or supplementary angles that are adjacent to each other, so they share a common side and a common vertex. Or you can have non-adjacent supplementary and complementary angles where they don't actually touch each other whatsoever. We also recognize that corresponding angles are angles that are congruent, assuming, of course, or knowing that the lines M and N there are parallel as an example. We also know that alternate interior angles are congruent. Again, M and N are parallel if that's the case, or we know that they're going to be parallel if we know that the alternate interior angles are congruent. Alternate exterior angles are also congruent. Same side interior angles are supplementary. And with that in mind, we now have everything that we need to define angle relationships. Knowing that we have those complementary and supplementary relationships, knowing that we have linear pair vertical angle, and we have the parallel line theorems and postulates, we can use that information to kind of determine angle measures that we're about to look at here. So we're going to go ahead and start with this first one. And in this case, they're telling us that lines N and P are parallel. So the first thing we like to do is label that information, and then they tell me the angle 2 is 50 degrees. Now I'm just going to start doing this right away because this is how I like to fill these things out. When I have this transversal Q cutting through the lines P and N, and I know that they're parallel, I'm just going to highlight the regions that are related to each other here. We're talking about these regions of angles here, right? So angle 2 happens to be a vertical angle with angle 4, so I automatically know that it's 50 degrees. But also angle 2 is corresponding with angle 6. That means that it's 50 degrees as well. And angle 2 also is an alternate exterior angle to angle 8. So angle 8 is also 50 degrees. Likewise, we can see that because angle 2 is 50, angle 1 is 130 degrees because it forms a linear pair with angle 2. And that happens to be corresponding to angle 5. And both angle 3 and angle 7 are vertical angles with respect to angle 1 and 5, so they're also 130 degrees. So the reason I like to do this is that when I'm given a singular angle, which I was given in this instance here, it's like a domino effect. It is the first domino that knocks down a chain reaction that allows me to determine all of the other angles in both regions from just the one. And actually there's only two angle values that we ever used, 50 and its supplement, the 130 degree angle. So when we were looking for the measure of angle 4, remember that originally we kind of stated that we know that angle 4 is vertical with angle 2, right? So it's vertical with angle 2 specifically. So that means that the measure of angle 4 was equal to 50 degrees for that particular reason. Now the measure of angle 3, we could determine that because that would have formed a linear pair with angle 2, right? So when we're talking about it being a linear pair, remember that means supplementary. So that means that the measure of angle 3 was equal to 180 minus 50, or 130 degrees. The measure of angle 7 could be found in in this case, because angle 3 is corresponding, right? So we have corresponding angles. It's corresponding, so we have angle 3 with angle 3, and so the measure of angle 7 is also equal to 130 degrees. And then, of course, if you look at angle 2, the original angle, and angle 8, those are going to be alternate exterior, right? So we have alternate exterior angles. And of course, that was with angle 2. Or you could also say that angle 8 is 50 degrees because it's a linear pair, right? You could say angle 7 and angle 8 are a linear pair. Or you could even say, it's vertical with angle 5. Right? There's so many different reasons you can justify. And so that's why you want to get used to using these different angle relationships when you're trying to figure out what the angle values actually are. And so that's an example of how I would come up with all of these angle measures from just that one angle measure value. So in this case, you want to take a moment, pause the video, see if you can select the correct option. But the correct option for this particular problem is this last option. Now, in this case, line M and line P are not given as parallel, and the reason we focus on them specifically is because line Q is the transversal that connects those two regions, and specifically those two regions are this region right here and this region right here. So angle 2 is corresponding to angle 10, and since we're focusing on those two regions, that would be line P and line M, not line N and line M, right? So that's why this option doesn't work. They do share a transversal, and they are in fact corresponding angles. It's just that we don't know that M and P are parallel lines. So looking at this example here, we want to go ahead and we want to prove or otherwise determine the measure of CFG. So labeling is extraordinarily important here. We have the segments AB is parallel to CD, CD parallel to FG, AC parallel to BD. So AB is parallel to CD, right? So we know that that's in fact true, and we also know that it's parallel to FG as well. So we are told what CBA actually is as an angle value. CBA is this angle right here. And I'm going to use blue, and it's described as a 37-degree angle. Likewise, angle ACB, which is this angle right here, is described as a 78-degree angle. What we're trying to show is the measure of angle CFG. So I'm going to highlight that in green. CFG is this angle right here. We want to know what that angle actually is. So let's establish some information that we know. We know that all three of these segments, these lines in other words, are parallel to each other, right? So we know that AB and CD and FG are parallel. We know that that's a fact. And we're going to use alternate interior angles to help us determine the measure specifically of this angle right here and this angle right here. Now, in this case, I don't necessarily need this angle that I just referenced below, but I'm just going to justify it as part of the problem. So the angle that I first highlighted was here. We can refer to that in this case as DCE. So the measure of angle DCE is going to equal 37 degrees. The reason for that is because it is an alternate interior with this angle right here. Likewise, I know that this angle is also 78 degrees, the measure of CBD. The measure of CBD is 78 degrees because it is an alternate interior with that angle. Now this is important because now what I need to focus on specifically, which I will now highlight in blue, is this entire angle here. And the reason I want to do that, and I'm just going to draw myself a little diagram on the side to show kind of why, is I've got this side length that starts kind of up at F right here, it goes to C, and I've got these parallel segments. We know they're parallel, right? And we're looking for this angle right here. We want to know what it is, but we actually have enough information to figure out what this angle is entirely. It's the combination of 78 and 37. Why is that significant? Well, the reason that's significant is because those form same side interior angles between two parallel lines. So if I know what the total sum of that angle there is, I can subtract that from 180. So in this case, we can refer to the total angle that's in blue that I highlighted as in the measure of, and let's use red here, the measure of angle DCF plus, in this case, the measure of angle, in this case, CF, and we'll just go ahead and call it CFG because that's what we're looking for, right? And so that's going to end up equaling 180 degrees because, again, those are same side interior angles. So on the other side of things here, when I'm writing on my answers, you see I'm kind of referencing the type of angle relationship because that helps me kind of keep track of why I'm able to say that. And I know that that measure right there of DCF is 78 plus 37. So now I just have an algebraic equation and my variable is the angle I'm looking for. So by adding those together, I get 115 degrees, and I can go ahead and subtract that now from 180 to get the measure of angle CFG. So when I subtract from 180, I now end up with 65 degrees for my answer. So the angle for CFG, the measure of CFG, is 65 degrees. So looking at this example here, we know that AB is parallel to CD, so we're going to go ahead and refer to that. AB is parallel to CD, and again, FG is parallel to those as well. So as I mentioned before, in fact, I can go ahead and just kind of take that statement that I referenced earlier, and I can just kind of copy that down because that is the exact same established fact in this problem as well. We know that they're parallel to each other, which is great. So now what we're looking for is the measure of FGB. Okay, so I want to make sure that it's clear we highlight what we're looking for. FGB is right here. That is now the angle we're looking for. Now we can go ahead and establish the facts, right? And what are the facts? That the measure of CDA, which is this angle right here, is 20 degrees, and the other measure that they're giving us is DAC. DAC is this angle right here, which is 25 degrees. Okay, so now I have that angle. So what I'm going to go ahead and do is I want to focus my attention on perhaps trying to figure out the relationship between FGB and this angle right here. Remember, if I draw out the lines kind of separately, just on their own, so there's two parallel lines, and we are seeing this segment right here, and that's going to be G and that's going to be D, and maybe I'll extend it out a little ways. We are given this particular angle right here. We're wanting to find that angle, and it is corresponding with this entire angle up there. Now that angle has been split, right? But we know that those angles are corresponding angles, right? So we're going to establish that angle FGB and angle, you could call it CDG or CDB, it doesn't matter actually. They are corresponding angles, and I'm just abbreviating the word corresponding right there, CORR. Okay, so that's going to come into play later because now what I recognize is that this angle right here is also 25 degrees. This angle here is 20 degrees. Why are those angles 25 and 20 degrees? Well, the reason why those angles are 25 and 20 degrees, and again, we want to be careful because the other thing that's a fact here that's established is, and actually I kind of jumped the gun a little bit because I said that AB is parallel to CD is parallel to FG and AC. I forgot to mention that AC is also parallel. I'm going to use a single mark here that those segments are parallel to each other. That allows me to then reference why those angles actually are going to be parallel to each other. That's actually true up here as well, by the way. I'm going to point that out because it does actually say that, AC and BD. So that's why I'm allowed to use both of those, right? So in red, I marked them as 20 degrees and 25 degrees. And we'll just mention that the reason for that is because those are alternate interior angles, right? So focusing on the angle up here, the one that I've referred to that we are saying is corresponding to the one we're looking for, we can go ahead and write down the measure of that angle value right away. The measure of angle CDB is going to equal 20 plus 25. and that's going to be a 45-degree angle. Because the measure of angle CDB is equal to the measure of angle FGB, that then implies that the measure of angle FGB is also going to be 45 degrees. So FGB is going to be a 45-degree angle. That is the reason why it is the same exact value as CDG or CDB. Okay, so we now know the measure of angle FGB, and in this case I'm kind of somewhat hand waving a little bit here because I mentioned that those two angles are 20, 25. I mentioned that they're 20 and 25 because they're alternate interior, and they are alternate interior. But the reason we're able to say that's because of the alternate interior angle theorem, right? So we're justifying a lot of these things using those parallel line theorems or postulates, or using the angle properties, which is what this lesson's about, right? So in this final example here today, we are going to go ahead and find all of the measures that we have, and we're going to figure out kind of like as a domino effect why they are the way they are, what the reason is behind why they are the values that they are. So these are parallel lines, and we're going to start with the region up here, 5, 6, 7, and 8. I'm going to start here first because I like to fill out different regions one at a time if I can, and it starts off with in this case, actually, it starts actually down here. Let's use orange for this. This whole region down here actually can be kind of filled out relatively quickly, actually, because they're giving us 10, which is 60, and they're giving us 12, which is 40. It would be my recommendation that we find all of the angles in that region alone first, and here's the reason why, because we've actually already worked with them. So I'm going to start with vertical angles. All right, so angle 13 is a vertical angle with angle 10. It is congruent to angle 10. Actually, let me write angle 10. And I want you to think because it's vertical, right? So it's a 60-degree angle. Angle 9 is a 40-degree angle because it is congruent to angle 12. And it's because it's a vertical angle. Now, if you notice, this forms a straight angle. Combined together, that is supposed to equal 180 degrees. So if I want to find the measure of 11, I can subtract 40 and 60 from 180 to get an 80-degree angle. That's how I can determine that the measure of 11 is an 80-degree angle. And of course, 14 is congruent to angle 11 because it is 80 degrees. So right away, I just knocked out, in this case, 9, 14, 10, 13, 12, and 11, with 10 and 12 already being given. So I've got 4 angles now that I know. And I want to go ahead and take a few of those angles and compare them to my group in green up there at the top. So take a look at angle 10. It's 60 degrees in the upper right quadrant, or I shouldn't say quadrant in this case because it's actually broken up into, it's like a quintet really because it's 5 pieces. But it's still in that region where it corresponds with this region, right? So 10 and 6 correspond. So that just tells me that angle 6 is also going to be 60 degrees because it's congruent to angle 10. And now it all breaks apart, right? Angle 8 is congruent to angle 6 because it's vertical. And so we know that's 60 degrees. And if we want to, we can see 13. We can see. There's two things you can do. If you look at 7, for example, 7 corresponds with all of this. That's 40 and 80 combined. So we can say that 7 is going to correspond with both of those angles. It's 120 degrees. That's certainly one way to think about it. Also, however, you can think of it as a linear pair with angle 6. So it has to be supplementary, so it has to be 120. Angle 5 is going to be congruent to angle 7 because it's vertical, so it's 120 degrees. So now I have all of those angles in that region, so I can focus my attention on the final region over here. I have to unfortunately compare it, however, only to this region. Why? Because these lines are not parallel. This transversal goes through non-parallel lines, so you cannot relate this region to that region, but you can relate this region to that region because these lines are parallel. So 1 and 14 are congruent. So whatever 14 is, which is 80 degrees, that also is going to be what 1 is. So that's 80 degrees. And then we have 4 matches up with 60 and 40. So that's going to be 60 plus the 40. Which, again, that makes sense because it's going to be 100 degrees. 3 is going to be congruent to angle 1 because it's vertical, so it's 80 degrees. And then finally, we said 4 was 100 degrees, so we can say angle 2 is congruent to angle 4, making angle 2 100 degrees as well. And we've now filled out our diagram. For your exit ticket, you are going to be tasked with determining what the measure of FGB is. I would encourage you to review the slides directly because we went over this exact problem. DAC is going to be this angle right here at 25 degrees, and then CDA is going to be this angle at 20 degrees. These are parallel according to what they've stated. Also these are parallel as well. Or at least I think, yes, they've stated that they are actually parallel. So that's why I've listed them out that way. So I refer you to the previous slides for that problem. For this problem, my suggestion is that you look at what lines are parallel. You are given the task of determining ABZ, which is this angle right here. And we are told that AXZB is 20 degrees. We're also told that the entire angle XZY is 40 degrees. So my hint to you would be to think about alternate interior angles in that instance to find the value of the missing angle. And then the last example, you're finding or trying to figure out, kind of based off the problem on the left, what is the actual relationship between FGB and CDB that it referred to. So this angle and that angle. What's the relationship between those two angles? That's going to be lesson 5.03.